Right. Right. Good morning, everyone. Online students, good morning. Can you hear me? Can you see the screen? Kindly please respond to me in the chat for me, guys. Online students, please check. Can you hear me? Can you see the screen? Feel free to respond to me in the chat for me. Go ahead, go ahead. Feel free to respond, guys, please. Come on. Can you hear me? Can you see the screen? Are you able to send me a message? Perfect. 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 Yes. Yes. A very, very good morning, guys. Very, very good morning. So, yes, you can hear me. You can see the screen. All right. Let us start our today's session. So, guys, yes, before starting our today's sessions, as always, let us just try to have a very, very small and a quick recap on the concepts which we have covered in our yesterday's session. From yesterday onwards, we started discussing about multi-threading concept. So before starting with multi-threading, we need to understand what is multitasking. Of course, we know what is multitasking. It is a process of performing multiple tasks simultaneously at the same time by a single processor in order to optimize the utilization of CPU. If you want to perform this multitasking in Java, we are having two options by using process-based multitasking and thread-based multitasking. Process-based multitasking, multi-processing, thread-based multitasking, multi-threading. And we have seen what is the difference between multi-processing and multi-threading. And I discussed about like what is actually a thread. 5 points. We need to say 5 points. Like first point, of course, a thread is a smallest unit of a process. Process acts as a host for a thread. At least one process is required to create a thread. And fourth point, the most important point, that is threads share same address locations. As threads share same address locations, context switching is easy in threads. And of course, we discussed about how to create a thread. We are having two ways. First one is by extending thread class. Second one is by implementing runnable interface. Both thread class and runnable interface, both are present inside which package? Java.lang package. And kindly please do remember, runnable interface is which interface? Functional interface. So obviously there would be a run method, that is abstract method, that is run method. So we need to override the run method. And I told you, if you want to start a thread, of course, by using start method, every thread by default, it will execute a run method. Kindly please do remember that. And actually before starting this concept, like before starting multi-threading, I told you one small point, that is we will not be able to guess the output in threads. So today we'll be trying to see that. Why we will not be able to guess the output in threads also, we'll be able to see that. So, and after that, yesterday I gave you some steps also, like how to create a thread, and how many totally 5 steps are there: either extending thread class or implementing runnable interface, overriding the run method, creating an object of your class, creating a thread class object, attach the thread, attach your class object to the thread and start the threads, as simple as this. And yes, Molly said context switching means switching between the threads. Yeah, obviously, Molly, context switching means, yes, switching between the threads. Your processor will be able to switch from one thread to another thread. So yes, these are all the concepts which we had covered in our yesterday's session. For example, you know what? Let me just try to create a thread. And do you remember which one is better? Extending thread class or implementing runnable interface? Which one is better? Runnable interface. Why? Because if we are trying to create a thread by implementing runnable interface, always there is a chance for our program to inherit one more class. Remember that. Okay. All right. For example, I'm going to create a thread by extending thread class. And here I'm just going to write run method, public void run method. And just let me try to write override and just a small for loop. Guys, please don't think like writing for loop is mandatory. No, we can write any code. The reason why I'll be writing for loop, we'll be able to get multiple outputs. That's it, not more than that. Okay, int I equal to 1, I should be less than or equal to 5, I plus plus, and here simply system dot out dot println, I'm going to write run method executd, run method executed plus I, just like that. Now let me go to my main method. Okay. Now inside this main method, I'm going to create an object for my class. All right. Equal to AOE. Come on. AOBJ belongs to class A. And I'm going to create a thread, new thread. Okay. Equal to T1 belongs to THREAD thread class. And what is this? THREAD. Okay. Thread class and AOPJ. Let me try to create one more new thread and here equal to T2 belongs to thread class, as simple as this. Okay. Now I'm going to write T1 dot start, T2 dot start, T1 dot start and T2 dot start. Now my question is, as of now, I'm trying to execute my T1 thread. I'm trying to execute T1 thread. Totally right now, how many threads are present in my program? I'm sorry, three. Three threads. Three threads are there. Main thread is also a thread. Main method is actually a thread. I told you this point when I discussed about internal architecture of JVM. Do you remember that? Internal architecture of JVM. On that day only, I told you. Anyways, let me just try to execute the code. Right click, run as Java application, Windows show view console. Okay. Can you see this? Exception. Where in thread. What is the name of the thread? Main thread. I hope you are getting the point here, right? Remember, main method is also a thread. Anyways, we'll be getting back to it later. Now, let me just try to keep it like this. Okay. Now, T1 thread, T2 thread. I am trying to start T1 thread. Now tell me, run method will be executed or not? Yes or no? Which class run method? Class A. Right now, if I execute my program, yeah, class A run method will be getting executed. If I'm trying to keep this in comment and I'm trying to call T2 dot start. Now also same question. Run method will be executed or not? Yes or no? 100% yes. Which class run method? Thread class run method will be getting executed, right? Our class run method will not be getting executed. Why, sir? Why? Because did we attach our class object here? No. Am I clear with that? Okay, okay, okay. Now I have a small question. Okay, right now we are trying to start first thread. Obviously, run method got executed. Now, sir, start method is present in which class? Start method is present in which class? Thread class. Okay. Run method is also actually present in thread class. I mean, when I say thread class, runnable interface. My question is, can I directly call run method like this? Can I directly call run method? Let's see. Right click, run as Java application. Am I getting my output? Wait, what is happening here? If we are calling start method, if we are calling start method, run method is getting executed. If we are directly calling run method also, our class A run method is getting executed. Yes or no? What is the difference? What is the difference between these two? T1 dot start, T1 dot run. What is the difference between? Okay, let me make this simple. Right now, I'm speaking about T1 dot start. In this case, a new thread will be created whenever we are writing start method, whenever we are using start method, a new thread will be created, and that thread, just a second, and that thread is responsible for, that thread is responsible for executing run method. Which class run method? That thread is that thread is responsible for executing the run method present in present in class A because of overriding concept. RIDDING. Don't get confused. Very, very simple concept. Whenever we are using start method, whenever we are using start method, a thread will be created. A thread will be created, and that thread is responsible for executing the run method present in class A. Okay. Whenever we are using T1.run, in this particular case, let me just, in this case, no new thread will be created. Absolutely not. Whenever we are speaking about T1.run, T1.run, no new thread. Basically, a thread is not getting created. We are calling, we are calling run method just like a normal method call. We are calling run method, which is present in thread class, just like a normal method call. For example, use method overriding. Method, I'm speaking about method overriding. We'll be trying to call parent class method. Which method will be getting executed? Child class method will be getting executed. Na? Same scenario here. As it is, same scenario. So in this case, no new thread will be created. We are calling run method just like a normal method call. As we are using, as we are using method overriding, as we are using method overriding instead of thread class run method, our class A run method will be executed. Class A run method will be executed. Very simple, very, very simple. Now, whenever we are using T1.start, run method is getting executed. Whenever we are directly calling T1.run, also run method is getting executed. What is the difference? Whenever we are using T1.start, a thread will be created, and that thread is responsible for running the run method. A thread, literally a thread will be getting created. We will be able to make that thread sleep. We'll be able to make that thread wait. We'll be able to synchronize that thread. A lot of operations we will be able to do on that thread. But here, T1.run, no new thread will be getting created. Basically, you don't have any option to create a thread. Directly, you are calling the run method which is present in thread class. As we are using method overriding, instead of thread class method, our class A run method will be getting executed. Just like normal method overriding. That's it. Not more than that. Please tell me, am I clear with this? Okay. Now we'll do one thing. Please tell me what about, just a second. Now I'm going to ask you for T2 dot start. T2 dot start. T2 dot start. Tell me. Try to tell me. In this case, come on, go ahead. In this case, a new thread will be created or not? Created on, yeah. Why it will be created? Start method. We are calling start method. Tell me. In this case, a new thread will be created, and that new thread is responsible for executing the run method present in thread class. not class A. We are not attaching the object now. So present in THREAD thread class, thread class, just like that. What about another scenario? That is, I'm speaking about T2. Just a second. Let me try to write T2 dot run method. Now please tell me in this case, tell me guys, go ahead. In this case, no new thread will be created. We are calling run method just like a normal method call. Tell me which run method will be getting executed? Tell me that is correct. Thread thread class run method will be executed. Normal method call, just normal method call. You need to respond, guys. Are you getting the point here? As simple as this. Again, please get back here. We are having an option to directly call the run method. But remember, whenever directly calling run method, thread will not be getting created. If thread is not getting created, how will we be able to perform operations on thread? No. Directly you can call run method also. It's just like a normal overriding. Normal overriding. So directly calling run method is actually not recommended. Is that clear? See, please observe here T1 dot start. T1 means thread 1. Thread 1. Am I attaching our class object? Yes. New thread will be generated, which is responsible for execution of class A run method because of method overriding. Because of method overriding. T1 dot run. Tell me. No new thread will be generated, but class A run method will be executed just like a normal method call. Means we are using overriding now. Same. When you're speaking about T2 dot start, a new thread will be generated. A new thread will be generated, which is responsible for executing or implementing thread class run method. When you're speaking about T2 dot run, no new thread will be generated, but thread class run method will be executed just like a normal method call. This is actually one of the most frequently asked interview point of view question. Question is, what is the difference between start method and run method? If you are calling start method, internally run method will be getting executed. If you are directly calling run method, means run method will be getting executed. So basically, why? Interview will ask you why we need to call start method. Why can't we directly call run method? Simple answer. If you're calling start method, a thread will be created and that thread is responsible for executing the run method. If you're directly calling run method, thread will not be getting created. Normally we are calling. Am I clear with that? Kindly please have this in your notes. Go ahead. Guys, we will be able to perform lot of operations on thread. We will be able to make the thread to sleep. We will be able to make the thread to wait, yield, join, synchronize, deadlock scenario, thread grouping, thread pooling, executor framework. Lot of things we'll be able to do if we are having a thread. Please go ahead. Have this. I request you to write little bit fast, little bit, just little bit. Feel free to write your own data. It's not mandatory that you need to write exactly the data which I have given. What you understand, frame your own sentences so that you will never forget. Online students, if completed, kindly please try to message me in the chat. Daytime, no worries, just a little bit. Boys, is it done? No. 1 minute, guys. 1 minute. 1 minute. Be fast. 1 minute. Okay. Let me ask you this, guys. Are you revising the previous concepts? Seriously. Yes. Please make sure to revise. Okay. Coming to the classes, listening to the classes. Okay. But if you are not revising the concepts, you will forget. Every day you are waking up by 5:30, 6 o'clock, you are coming here. That is actually very good. That is actually very good. So make sure to revise. If you are not revising all these, whatever the pain you are doing, it will not be worth. So revise every day. Just make it as a habit. Just make it as a habit. That's it. Every day we'll eat breakfast. Every day we'll watch some kind of reels, something like that. Like that, every day you need to revise. Make it as a habit. How we will eat, how we will bath, how we will do the regular normal things. Like that, revision also keep that in your schedule, right? Please don't miss that. I'm saying this multiple times. Why I'm saying this? In advanced Java, currently, you know that I'm dealing in advanced Java batch. People who are having a good knowledge in core Java, they'll be enjoying concepts in advance. People who are not having revision means they know the concept, but they need little bit time to get back to the topics. They'll be having a trouble. Advanced Java will not be spoon feeding. Remember that. Okay. So very soon we'll be completing our core Java. I already told you maximum by um, yeah, March third week, I guess. Third week. I told you, right? Maximum by March third week will be winding up. So after that, in between only, if I started advanced Java, you can join. Are you getting the point? Currently, whatever the advanced Java batch which I am taking, in another 10 days, it will be completed. Once that batch got completed, after maybe 1 week, our team will be trying to schedule one more new batch. At that time, you are eligible. You can come and join for that. Are you getting me? Why? Because in advanced Java, starting 20 days, we will be discussing about JDBC. JDBC, how to connect our Java program to the database. 20 days. Advanced Java will be totally 50 days. First 20 days, JDBC. After 20 days, then we will be dealing with the server side programming, servlets, JSPs. So within these 20 days, in the meantime, we'll complete our core Java also. And in advanced Java, that is JDBC, I'm not going to spoon feed you the previous concepts. No, no. I'm not going to give you an idea about again OOPS concepts. I'll directly use the concepts. I'll directly use static related concepts. I'll be directly using wrapper classes concepts. Wrapper classes, this keyword, OOPS concepts, exception handling. We already completed exception handling, right? Multi-threading will not be using in advanced Java, maybe in Spring Boot, not in advanced Java. Next, IO streams. Yeah, we'll use IO streams. We'll use collection framework. So again, revise, revise. Time is actually very less. Please revise. Okay. All right. I guess it's completed. Molly, in advanced Java, do we have Spring Boot also? No, 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 no. Spring Boot is different. Advanced Java is different. Advanced Java will be completed within 50 days. 50 working days, advanced Java will be completed. But when you're speaking about Spring Boot, it will take 80 to 85 working days. Just like core Java, Spring Boot is also going to take. Mostly, I will not be coming for Spring Boot. It will be dealt by any other trainer. My slots are a little bit busy. But advanced Java, I can promise. Clear? If I'm coming for Spring Boot also, you will feeling, Are again Spring Boot also, Kishan only. You'll be feeling bored. So, no. But for advance, I'll be there for you and laptop, hands on. You will love it. Advance, just wait for it. You will love advance if you are having good revision skills on core Java. Please do that. Please do that. You have absolutely no idea how much core Java is important. In your interview, if you're getting 40 questions on an average, do you know how much time interview will take? If you're going for an interview, how much time that interview will happen? 5 minutes? No. 10 minutes? Absolutely not. Half an hour? No. Nearly 40 to 45 minutes it will be there. In that 40 to 45 minutes, nearly half an hour you will discuss about core Java only. Starting. Starting, yes. The people who are already working, they may know this. Nearly 20 to 25 questions you will be getting on core Java. If you are failing at core Java, then done. Close. So revise, revise, please revise. Okay. All right. Yeah, yeah, of course. Yes. Now, so is it done, guys? Okay. Now let us speak about life cycle stages of a thread. Life cycle stages. According to the Java documentation, when you're speaking about thread life cycle stages, there will be just a second. 1, 2, 3, 4, 5, 6. According to the Java documentation, there are 6 life cycle stages. New stage, runnable, runnable, blocked, waiting, timed waiting, and terminated state. So totally 6 life cycle stages are there. According to programmers' perspective, we can add one more life cycle stage, that is running stage. So totally you can say either 6 or 7, no problem. So let's try to understand these life cycle stages. You know what? For example, let me try to give you an example for these life cycle stages. Okay, today I came to the office. Generally, every day, what happened, I'm ready from my home. I want to come to the office. Our home is located at the second floor. I'm ready. I'm ready. Okay. But I'm not yet started. I'll wait for 5-10 minutes. Are you getting me? Every day I'm going to start to my office by quarter to seven. Quarter to seven. If I'm ready by 6:40, I'm not going to start. I'll wait. I'll wait for 5 minutes. Ready to start, but not yet started. New state. New. New stage means the thread is created. Thread is created, but not yet started. New state. Okay. I came down. Second floor to ground floor. I came down. I forgot my helmet. I'll make a call to my wife to please bring me the helmet. Okay. I'm already starting. Not yet started, but I am waiting for the resources. In my example, what is the resource I'm waiting? Helmet. If that resource came, then I can start. Runnable state. Runnable state is the thread is about to start, but it is waiting for the resources. Sir, what is it resources? Who is going to give you? Yeah, I'll see. I'll show you. Wait for it. Am I clear with that? First one. Thread is created, but not yet started. New state. Runnable state. Thread is created, about to start, but it is waiting for the resources. Stage 3, started. Started, running state. I started to my office. Are you understanding me? Thread execution started. Thread is running stage. Okay. Now, when I'm coming to my office, there is a, let's consider like flyover is there, flyover, and they blocked the flyover. They blocked the flyover. Why? Why? Because some VIPs are coming. They need to first go. They need to first give that VIPs a chance. Are you understanding me? I'm not speaking about signals. I'm not speaking about signals. Generally, whenever we are traveling through road, sometimes police will block us. Na? They will make us wait so that other threads can go. Are you understanding me? Blocked state. Blocked state means intentionally we will block the execution of the thread so that other threads can continue their execution. Blocked state. Okay, blocking is done, completed. Again, I started my journey. Signal came. Signal. Red signal. Waiting state. You know, in some signals, there will be countdown will be there. Na? Like I will be able to know how many seconds I need to wait. Timed waiting state. In some signals, time will not be there. I don't know how much time I need to wait. I need to wait until that red light turn to green. Waiting state. Are you understanding the difference between waiting and timed waiting state? Waiting state means we don't know when the thread will continue its execution again. There should be one more thread to inform the thread to continue. We don't know when the thread will continue. Timed waiting state, we 100% know when the thread will be again resuming its execution. Did you remember object class? Object class. In object class, we did not discuss some methods. Like we did not discuss anything about wait method, notify, notify all. Did you remember that? These are used for waiting and timed waiting state. I'll show you. This particular concept is known as inter-thread communication. When I discussed about first object class on the day, I told you, guys, wait method, 3 versions of wait method, notify all methods are there. These 5 methods we'll be discussing whenever we're dealing with multi-threading, I told you. Waiting, timed waiting state. Okay, once, okay, everything is done. Again, I came back to my office. Now my journey is terminated. I'm done. I'm done with the journey. That's it. Terminated state. Are you getting the point here? So one more time. According to the Java documentation, there are 6 life cycle stages are there. First one, new state. Thread is created but not yet started. Second one, runnable state. Thread is actually about to start, but it is waiting for the resources. Third one is blocked state. Intentionally, we will block the execution of the thread. That particular concept is known as actually synchronization. Synchronization. Yep. Wait. I think we came across this word synchronization before. When I'm impressed. String buffer, string builder. Did you remember that? Intentionally, we will block. Okay, that is blocked state. Waiting state. In waiting state, intentionally, we will stop the thread execution, and we don't know when the thread will again continue its execution. Time in waiting state, we will give a time. Predefined time we'll be giving like 3 seconds, 5 seconds. So until 3 or 5 or 10 or 20, whatever the time you have given, until the time is completed, the thread will be in waiting state. That is actually known as timed waiting state. Once the execution is completed, yes, done, thread execution is done. That will be like terminated state. Simple as this. Am I clear with that? No need to write all this. I'll upload it in the Google Classroom. No need to write. Okay. Now, yes, that's what I told you. According to the Java documentation, on paper, we are having 6 life cycle stages. Java documentation. According to programmer's perspective, we will add one more also, running. According to the documentation, only 6. But running is also there. Na? It is not mentioned in the Java documentation, but we will add one more also, running state. As simple as this. Got it? Okay. Now, let me just try to write one small program here. Okay. Right now, we are trying to execute the thread. Oh, just let me try to start T1 dot start. Okay. Right click, run as Java application. We'll be able to get our output like this. Guys, basically there are 2 types of thread applications will be there. 2 types. First one, single thread application. Single threaded application means, you tell me, what do you mean by single thread application? You. Only one, not only main method, only one thread. in our program, if we are having only one thread, that is actually known as single thread application. Multi-thread application means two or more than two threads. If, for example, right now, is it a single thread application or multi-thread application? Multi-threaded. Multi-threaded. So multi-thread. Main method is there. Na? Main method is a thread and thread one is also there. Am I clear with this? Okay. Now, just types of thread application, single thread and multi-thread. That's it. Very simple, not more than that. Now, I want to execute. Okay, right click, run as Java application. Fine. Run method is getting executed. Let me try to create one more thread here. This is T2 and T2 dot start. Now, let me keep this in comment. Okay, right click, run as Java application. Please tell me which thread executed run method, T1 or T2? T1 thread. Okay. Now here also one more time, right click, run as Java application. Tell me which thread executed run method. Okay, right now I'll be able to say T2, but if there is a chance that I'll be able to give a name for my thread, name for my thread, that would be easy for me to understand. Na? Yes or not? So I'm going to give a name. T1 dot set name. Let me just try to write first thread, and I'm trying to provide a name for my T2 also, and the name would be something like second thread. First thread and second thread. Okay. Now, what we are trying to do here, set the name. Now, I want to get the name also. Get the name. So, inside the run method, I'm going to write a line of code, thread thread dot current thread. Just a simple line of code. Try to explain me what is happening in line number 8. I'm not speaking about the implementation of that method. Just by looking at line number 8, what can you analyze? Now, again, you are speaking about the implementation. I'm not speaking about implementation. Just by looking at line number 8, what can you say? Now, more clear. Now, that is amazing. Yes, that is correct. Very good, Tali. That method is a static method. That method is a static method. No one should be able to say that. I mean, directly we will be able to understand that. Yes or no? Which methods we can call with the help of class name? Tell me. Which methods we can call with the help of class name? Only static methods. Now, okay, I am trying to call a method. How I am calling the method? With the help of class name, na? Yes or no? Guys, please respond. Ra. This is what revision makes. This is what I told you. Okay, we are trying to call a method, current thread method. Tell me one thing. Yeah, online students. Shrikant, yes, that is good, buddy. That is good. Okay, now coming back here. Current thread method is a static method. Tell me, is it parameterized method or non-parameterized method? Non-parameterized method. Okay. Now let me just try to show you current thread method. Where it is present. Just a second. Please tell me current thread method. Where it is present? Thread class. And again, please tell me current thread method is a static method or non-static method? Static method. And now, what is the return type for this current thread method? Thread. Return type for this current thread method is thread. What is a thread? Thread is a class now. Come on, Ra. Whenever a method is having a class as its return type, what we need to return? its object, right? So here, whenever we are writing this current thread method, what this current thread method is going to do, which thread is executing this run method, that thread object will be returned. One more time. Currently here we are having two threads, first thread and second thread. Come on, yes or no? Now, if I am trying to write, if I'm trying to execute t1 dot start, which thread will be executing this run method? First thread or second thread? First thread. That first thread came across current thread dot, thread dot current thread. Then that object means this object will be returned here. On top of that object, I am trying to call get name method. Get name method. This is method chaining. Yes. What would be the return type for get name method? Just try. String, absolutely. Let me just try to like string. I'm just trying to give name equal to like this. Now, please let me just try to write system dot out dot, you know what? Okay, I'll just try to keep it like this. And here, system dot out dot println name plus has entered entered run method. And here, just let me try to write simply NAME name, just like this. And after that, let me just try to, okay, completed executing, COMPLED completed executing run method. Completed executing run method. Did you understand my line of code? If possible, kindly please try to respond. Yes? Now tell me what happens. I'm trying to call start method. Tell me what would be my first output. Tell me what is my first output. Go ahead. First thread has entered run method. After that, first thread, 1, 2, 3. For loop, 1, 2, 3, 4, 5. After that, first thread, tell me, first thread completed executing run method. Right click, run as Java application. Am I clear with this? Okay, let me just try to, basically, this is my output. Okay. Now, I'm going to write, let me just try to execute t2 dot start. Now tell me what is my output. Please feel free, go ahead. Second thread has executed, like second thread has entered run method, second thread 1, 2, 3, 4, 5. After that, second thread completed executing run method. Obviously the same output. Okay, just let me try to keep it like this, right? Now, let me just try to remove this. I want to start both the threads. I want to start both the threads. Now tell me what would be my output here. Please go ahead. First thread has entered run method. 1, 2, 3, 4, 5. First thread completed executing run method. After that, second thread. Yes or no? Let's go. Right click, run as Java application. Wait, what? First thread entered run method. Okay. Why suddenly second thread came? Okay. Let's execute for one more time. What? Okay. One more time. One more time. One more time. Okay. Just are you observing me? Now tell me what is the first point I told you before starting multi-threading? Absolutely. We will not be able to guess the output in threads. Why? Why we are unable to guess the output, sir? We are calling first thread 1. After that, we are calling thread 2. Yeah, you are calling. You are calling first thread 1, after that thread 2. I'm not saying no for that. But you are not the person who is going to start the thread. You are not the person who is going to decide which thread should start its execution first. Then who is going to decide? Who is going to decide? Thread scheduler. Thread scheduler will decide which thread should start its execution first, basing upon two aspects. Let me just try to write like this. Thread scheduler will decide which thread should start its execution, which thread should start its execution basing on two aspects. Basing on two aspects. What are those? First one is thread priorities. What? Yeah. Every thread will be having a priority. Thread priority. Second one is underlying operating system. Your machine also should support. Your laptop also should support. Otherwise, no, you will not be able to get the data. Let me make this simple. For example, I'm having a normal mobile. You are having a flagship, either, let's go with Android. You're having a flagship Android mobile, S28 Ultra, I guess. Okay. Now we are having a game, Call of Duty mobile game. Who is actually playing that game? Anyone plays that game, Call of Duty? No one? Okay, no worries. It's a online game, just like PUBG kind of thing, right? High definition game. Mine is normal mobile. Yours is flagship. In which mobile the game would run smoothly? Flagship. Is the code different? Game code is same, but in my mobile it will not work properly. Why? My system, my mobile is actually not supporting. My processor is actually not supporting. My hardware is not supporting. Are you understanding the point here? Code is okay. Code is okay, but my machine is not supporting. As it is exactly the same here for threading concept also, multi-threading concept also. I'll show you. I'll show you. For example, one more time. Who is going to decide which thread should start its execution first? Thread scheduler. Okay, basing on how many aspects? Two aspects. First one is thread priorities. Second one is underlying operating system. When you're speaking about thread priorities, thread priorities varies between, just a second. Thread priorities varies between 1 to 10. 1 to 10. Okay. Now, let me just try to write like this. Minimum priority is 1. Minimum priority. Normal or default priority is 5. Maximum priority is 10. For example, let me get back here. Thread dot current thread dot get priority equal to int priority. Okay. priority. Let me just try to give the priority here. Plus priority plus just like this. Are you understanding why I have written like this? Please tell me. My intention is after this, there should be a parenthesis, and inside that, I want to print its priority. Right click, run as Java application. Tell me, what is the priority of both the threads? 5. Why 5? Normal or default priority for a thread is 5. Sir, can we set the priority? Yeah. We'll be able to set the priority. Let me just try to set the priority. T1 dot set priority. T1 dot set priority. For T1, let me try to give minimum priority. Minimum priority. For T2, I want to give, okay, just max priority. Either I can write like this. This is actually absolutely valid. Otherwise, simply I can write 1. These are static variables. Public, static, final variables. You need to respond, guys. Okay. Directly you can write that variable name, or simply, just a second. Let me try to keep it like this. Or simply we can give 10. No problem. Now, minimum priority, thread 1. Maximum priority is thread 2. Sir, can I give 100? Yeah, you can give 100. You will not be getting any error here. But tell me one thing, what is the legal range? 1 to 10. So, do you think that is it a legal argument or illegal argument? Read. Illegal argument exception. Are you understanding me? Come on. Okay. Now here, I'm going to give the priority as 10. I can give any number like 1 to 10. 1, 2, 3, 4, 1 to 10. I can give any number. Now tell me, right now, according to my code, which thread should execute first? T1 is having minimum priority. Which thread is having more priority? Yeah, tell me. Code is there. Literally, it's on the board. Tell me which thread is having more priority, T1 or T2? T2. So which thread should first start its execution? T2. Let's go. Let's try to check that. Right click, run as Java application. First, which thread started? Tell me. First, which thread started? Tell me. First thread. Okay. Let me execute for one more time. Now, which thread started? Again, first thread came. In between, first thread came. Sir, then what is the use of those priorities? Again, thread scheduler will decide which thread should start its execution basing on 2 aspects: thread priorities and underlying operating system. Your machine also should support thread executions. In order to make that happen, minimum your machine should be having 16 GB of RAM above. Minimum. Then only you will be able to get that. Otherwise, no, absolutely not. This is the reason we'll be saying we will not be able to guess the output in threads. Code is correct. Code is absolutely correct, but our machine is not supporting. Just like I gave an example for mobile, na? Code is same, but in some mobiles it will work flawlessly. In some other mobiles, it will be having a problem. Glitches will be coming, lagging will be there. You need to respond, guys. Are you getting the point here? Again, we are not the person who is actually starting the thread execution. We are not the person who is actually deciding which thread should start its execution. Who is going to decide? Thread scheduler. Sir, but are you saying that we will not be able to control the thread executions? No, we will be able to control the thread executions. Not every time, sometimes. In some cases, we'll be able to control the thread executions. That is by using some methods like join method, sleep method, yield method, interrupt method, wait, notify all, synchronization concept, we'll be able to control. We'll be able to control. Are you understanding the point? Online students, I want you to kindly please respond. Please respond. Please respond. That is good. Okay, sir, Mauli, you're asking, sir, here both the threads are doing the same task. How can we say multitasking? Wait, Mauli, I did not give you an idea about that multitasking. Wait for it. Right now, my intention is you should be knowing why we will not be able to guess the output. When I gave you an example on multitasking, on the day you will be able to know that. Just wait for it. Up to now, is it clear? My intention right now today is why we cannot guess the output in threads. We are not in charge. Who is actually in charge? Tell me, who is actually in charge? Thread scheduler. Am I clear with this? Mauli, is that clear, buddy? If possible, kindly please try to respond to the chat for me. Okay, that is good. That is good. Okay, just a second. Okay, getting and setting the name of a thread. Please keep a siding as just a simple side heading. Just a simple side heading. Getting and setting the name, okay, but please try to write this. Understanding thread priorities. Understanding thread priorities. Not on a small point for me. Every thread will be having every thread will be having a default priority, that is every thread will be having a default priority, that is 5. Next point. Thread priorities varies between thread priorities varies between 1 to 10. Thread priorities varies between 1 to 10. Next point. We can increase or decrease the priority of a thread. We can increase or decrease the priority of a thread by using write like this, set priority method, and please make sure to write its parameter also, int priority method, just like this, by using like this. After that, yeah, we can get the priority of a thread. We can get the priority of a thread by using, tell me, which method, guys? Get priority method. Very simple. By using get priority method. Next point. Please keep this point in star. Thread priorities are highly system dependent, comma. Thread priorities are highly system dependent, comma. We should always keep in mind that we should always keep in mind that underlying platform should provide, we should always keep in mind that underlying platform should provide support for underlying platform should provide support for thread scheduling, support for thread scheduling based on their priorities. Based on their priorities. Note down this entire slide for me. Go ahead. There are three static variables in thread class for priority: public static final int min underscore priority, public static final int norm. Norm means normal priority or default priority. Public static final int max priority. Static variables. All these are static variables. Remember that. Banu. Banu, you're asking, sir, if the scheduler is controlling the priorities, why we need to define? Banu, scheduler is controlling the priorities. Remember, that depends upon your operating system. If your machine is supporting thread scheduling, then whatever the priorities which you are giving, according to that only, threads will be getting executed. If you are having good configuration systems, yeah, you will be able to get executed. Yes, absolutely yes. Get not exactly abstract, it is native method. Native method. What are native methods? Exactly. Exactly. How? That's what I told you. You are speaking about like Java concept, but that is native method. Got it? Is it done? Okay. Kindly please try to have this program in your notes. Go ahead, please. Okay, Shrikant, you are saying that, sir, in real time, we don't know what configuration system user will be using, then output will be different for different users. Then if you are using multi-threading, not exactly, buddy. Okay, that's a very good question. Let me make this simple. Generally, we will be using this multi-threading for projects like related to gaming, Shrikant. Okay. In general, we'll be using this multi-threading for the projects related to gaming. And you know what? Whenever you're trying to work or else play a game, there will be some system requirements for that game. That is the reason we'll be giving them, right? That is first case. Second case is not every time we will not be able to guess the output. As I told you, we will be able to control the thread executions. Yeah, we'll be able to control the thread executions. Which thread we want, okay, for example, particular thread. We can make that thread execute also. We'll discuss that. But did you got it, Srikanth? Generally, yeah, I understand your question. Your question is absolutely valid. For example, sir, we create a project and user don't have any, we don't know what about which machine user is using. In that case, what happens? Yeah, that's what I told you. Generally, we'll be using this multi-threading for gaming, and particular game will be having some system requirements, system specifications will be there, right? I believe you're getting me, Shrikant. And of course, we'll be able to control the thread executions also. I'll show you that. Not by today, obviously by tomorrow. Okay, Shrikant? Great. Banu, sir, is configurations are not defined in the design phase. Yeah, yeah, it will be defined. Banu, we will be having that TDD, technical design document will be there, na? In our whenever we are starting with a project, at that time it will be there. Yes, it will be there. That is the reason for some projects we'll be using some laptops, for another projects another laptops. It's not like only one laptop we'll be using for everything. Yes, yes, absolutely yes. Not done. Can I scroll up to line number 17? Okay, please. I advise you to write the shortcuts also, please. Comments also. Is it done? Right. Dot. That's it, guys. That's it for today. Tomorrow we'll be discussing about how to control the thread executions. There are some methods are there: join method, sleep method, yield method, interrupt method, by using synchronization. All we'll be trying to discuss tomorrow. Okay. Done. If complete, you can leave. Online students, I guess you enjoyed our today's sessions. If possible, kindly please try to message me in the chat. If possible, kindly please try to message me in the chat, guys. Go ahead. Okay. That is good. That is good. That is good. Feel free if you want to write, you can write, no problem. Satyasree, if you are using systems of same configuration for executing same program, then output will be same. Satyasree, I told you one statement before starting multi-threading. We will not be able to guess the output in threads. For example, Satyasree, let me make this simple, Amma. Simple. You are having, let's consider like two iPhones. Okay. Same configuration, high-end iPhones you are having. If you switch off and restart them, are you 100% sure that both the iPhones will restart exactly at the same time? I believe you got the answer for your question. Okay, Amma? Yes. Yeah, that's the reason. That's the reason. We'll not be able to guess the output in threads. Threads are designed like that. Okay. Right, Amma. Right, right, right. See you guys. See you tomorrow. Thank you. Thank you for listening. Have a great day. Tali, is it done?